Hey guys, and welcome to a very short, sweet, and useful episode of trigonometry. Today we're looking at the special case of the 30, 60, 90 triangle. What does this mean? Well, it means a triangle that has the angles 90, 60, and 30. So we're going to see that there is a very special relationship that we can use here to simplify our lives. So here we have a 30, 60, 90 triangle. Don't believe me? Well, here's a protractor. I'm going to hold it up to one angle, and you can clearly see that reads exactly 30. Now, I could hold it up to this angle and verify that this is indeed 60 degrees, as you can see here, but I didn't really need to do that, did I? I already found that this one was 30. So, we know that the internal angle of a triangle, the internal angle of a triangle is equal to 180 degrees, meaning that if we added up the three angles of any triangle, they're going to add up to 180 degrees. So as soon as we knew this one was 30 degrees, we already knew that 90 degrees was over here. So all we needed to think was, well, what's 180 minus 90 minus 30? And the answer was 60. So our third angle had to be 60. So we do this a lot in trigonometry. We don't have to solve for three angles using trig operations all the time. Once we have two, we can just use this very simple property of triangles to find the third. So that's how we know the angles. So I'm going to give this a little erase. All we needed to know was that we have a 90-degree angle and a 30-degree angle. What happens next, as you can see, the rule is that in a right angle triangle, the length of the side opposite the 30-degree angle. So here's a 30-degree angle. The side opposite it is right here. This side is equal to half the length of the hypotenuse. So let's see what that means. Here I have a trusty ruler. I'm going to measure the length of my hypotenuse. And in this case, I'm seeing that it is 12. So 12 centimeters is my hypotenuse. Well, let's see how long the side opposite the 30 degrees is. It's no surprise that we see it is 6 centimeters. So this is true for this triangle, but it's true for any 30-degree right angle triangle. If it is this triangle, 30, 60, 90, then whatever the lengths are, this property will hold true. So if this was 10, this would be 5. If this was 2, this would be 4. You see what I'm saying? So let's see this in action. Okay, so let's use our 30-degree rule to find the length of this side here. We always have to name our triangles, so we'll name this triangle ABC, just to make it easy. So we want to find the length, the measure of AB. So this length right here. Well, we could just say it's going to be half the length of the hypotenuse because it's opposite this 30 degrees and it's a right angle triangle. So we can simply say it's going to be 42 divided by 2. So we found that it's 21 centimeters. Pretty simple. We could also find it using our ratios. If we're working through a complicated problem and we don't recognize, our brain doesn't click in, oh, this is a 30-degree right angle triangle, I could use this cool rule, then we can still use our operations. We have an angle, we'll call it theta. We have the hypotenuse, and we're looking for the opposite side. So what rule is that? Well, so is sine of theta is equal to opposite over hypotenuse. So we could put in our values. The sine of 30 is equal to our unknown, opposite, over our hypotenuse, which in this case is 42. And we're going to find, once we multiply both sides by 42, sine of 30 multiplied by 42 is going to equal our opposite side. Do this. Plug sine of 30 into your calculator. You're going to find that you'll get, not surprisingly, 0.5, a half. So a half of 42 will equal the opposite. So if you're always going to be plugging sine of 30 into this, then you're always going to be multiplying a half times the hypotenuse, and so you're always going to get a value which is half the hypotenuse for the opposite side of the 30 degrees. So you can see there's a reason for this rule. Another example. This rule works the other way as well. Now, if we wanted to find, let's read this example. To the right is a drawing of a super steep ski hill. So here's the slope of the ski hill right here. What angle does the slope make with the ground? So we're looking for this angle. Well, first of all, let's name our triangle. We're going to name this one SAT. S-A-T. Okay, so we're looking for angle STA. Well, if we wanted to do that, we could use our trig rule. So I'll just do it down here real quick. Okay, what am I looking at? This will be my angle theta. I have a hypotenuse and I have my adjacent side. So that means I'm going to use cosine. Adjacent over hypotenuse. I'm going to solve for theta, so I'm going to end up with something like this. Theta is going to equal the arc cosine of the adjacent over the hypotenuse. I can sub in my values, solve for theta, boom, bam. Sure, that's not so bad. We can do that absolutely. Or we could recognize, hold on, this value here is my hypotenuse, and it's twice the size of this side right here. Well, the fact that it's a right-angled triangle means that for this to be true, the side opposite here must be 30. So the rule works both ways. If you have a hypotenuse and the short side here is half its length, then the angle opposite the side half the length of the hypotenuse is 30 degrees. Which means, okay, internal angles of a triangle, 30 over here, 90 over here. Well, 180 minus 30 minus 90 is going to equal 60 degrees. So we found our angle very simply. So angle, we called it STA, is equal to 60 degrees. Very quick, very simple. It's going to help you save time on your exams. It's going to help you solve problems with great ease and poise. So enjoy, and I will see you in the next one.